Good morning. Today, or this one video is on box plots. It's an FRQ from 2010, and it's also involves histograms. This is page 59 of the note spiral. As a part of the United States Department of Agriculture's Superfund cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. Three of the target sites were River X, River Y, and River Z. They had become contaminated with pesticides because they were located near an abandoned pesticide dump. Measurements of the concentration of Aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. The box plots shown below display the 5-number summaries for the concentrations in parts per million of Aldrin for the 20 locations that were sampled in each of the 3 rivers. Once again, when they cite 5-number summaries, what they're referring to is the minimum, Q1, the median, Q3, and the max. All right. Now, if the minimum had been an outlier, that still would have been one of the numbers in the 5-number summary. Okay, so it's always the minimum value, whether it's an outlier or not. It's always the maximum value, whether it's an outlier or not. All right, part A says compare the distributions of the concentration of Aldrin among the 3 rivers. Part B says the 20 concentrations of Aldrin for River X are given below. Construct a Stemplot that display the concentrations of Aldrin for River X. Let's do part B first. So I'm going to want to put all these data values into my calculator, and I've already done that. I put them all into column L1, and so you can see that I have 3.4, 4, all the way to 4.6. So I have all the values in my calculator, and they want me to create a Stemplot. So at this point, remember which column you put it in, and I want to get these in order from least to greatest. So here we go. Second, quit. So I go to clear screen, and then I want second followed by the stat or list button. Arrow 1 over to operations, and I press enter. Now I have sort A. Well, I'm going to press second, and then whatever column number you put your data in. Mine's in 1, so I'm going to press a 1 and hit enter. So it says done, so I should be able to go to stat edit, and should be placed in order. And sure enough, 3.4, 3.7, 4, 4.2, etc. So everything's in order least to greatest. Now this Stemplot's a little bit different than the ones we've done before because it has a decimal, but still the same rules apply. The number farthest to the right is the leaf, and the other numbers make up the stem. So 3.4, 4.0, 4.2, etc., etc., etc. There were no value. If I scroll down, I go from 5.6 to 7. There's no values for 6. I never get to skip a stem. Even if there's no leaf for a stem or there's no values, this right here is a number line, and you don't get to skip values on the number line, so it has to be there. Please do not forget to have some sort of key. Now I use 7.3, but I could have even used 6.1, which we don't even have values for, as long as I have a key explaining what it is in the label. So there you go. So that gives me that, and when I look at that, I go, hey, you know what? I have a gap. What do you know? Or I have 2 distinct clusters, at least a gap. All right? So now we're going to go to part A, compare the distributions. So when I'm comparing the distributions, if we have unusual features, we should talk about them. We don't. But we can definitely see center. We can talk about the spread, and we can talk about the shape. The center, in this case, is probably easiest to talk about the medians. And the median of X is larger than the median of Y, which is larger than the median of Z, just by looking at this value. Now, if you can tell what the value is, that's great. But the median of X is greater than 5. The median of Y is about 5. Z is less than 5. And you can estimate them if you want to. As far as spread is probably fairly easy to see because X is spread out further than the others. So X has the greatest spread, all right? It also has the highest interquartile range. So it's got the largest range. It also has the largest interquartile range. River Y has the second largest spread and the second largest interquartile range. And River Z has the smallest range or smallest spread and the smallest interquartile range. Now, when we get to shape, this is a little bit more challenging. So when I look at River X, it looks like this, the distance from here to here looks less. So the distance from the minimum to the median is less than the distance from the median to the maximum. So in that case, I'm going to say that it appears to be stretched or pulled a little bit to the right. River Y, the median is almost in the middle. It's not quite. So I can say it's approximately symmetric. I can make the argument that this distance to here is the same as it is from the median to the minimum is about the same as the median to the maximum, about the same. Arguable, but it's somewhat symmetric, or approximately. And when I look at River Z, it's definitely skewed to the left. The median is definitely, the minimum to the median is definitely greater than the median to the max. So I need to write that out. So I'm going to let you, I'll read through this real quickly. And River X is skewed right and has the highest range, IQR, and variability. Quite frankly, if you talked about the highest range or interquartile range and didn't mention variability, you'd be good to go. River X also has the highest median, with the 50% of the readings being greater than 5. All right, 50% of these readings are greater than 5. It's actually more than 50%, but we don't know how much more. River Y is reasonably symmetric and has a median of 5, and its range is the second largest. River Z is skewed left and has the smallest range, IQR, and variance. It has a median of 4.3, or you could just say a median less than 5. All of its readings are below the upper 50% of X. Notice that I made some I didn't just describe each distribution, I made some comparisons between them. And then part C says, describe a characteristic of the distribution in River X that can be seen in the stem plot but not seen in the box plot. So this is River X's box plot. This is River X's stem plot. When I look at that, I look at River X and I had no idea that there was a gap, but I can see it in the stem plot. So that's a fair look. Part C was very easy. The gap at 6 cannot be seen in the box plot, but is visible in the stem plot. The stem plot appears to show 2 clusters, one centered at location 4 and one centered between locations 7 and 8. So whenever you talk about stem plots, make sure you talk about centers, all right? I mean, whenever you have multiple clusters, I said that wrong. Whenever you have multiple clusters, describe the center of each, please. It's not even bad to describe the range of each. I didn't, but as long as you had center and said that there was a gap, the difference was the gap, you'd be good to go. Discussing the range is also good. And that should close out 59. Thank you.